Bismillahirrahmanirrahim. So we're going to continue with chapter 11. Right. So chapter 11 is about radical functions, equations, okay? And previously we talked about radical functions, and the basic equation is this, right? Correct? And then we have graphed these. When you graph them, they look like this, correct? This being the pseudo-vertex, Vx, Vy, okay? The book calls them HK, which is okay. And I suggested previously that it's convenient that the radical function looks like a radical sign, right? Minus that would be extreme radical. It's plain right. Yes? This is a radical function. Everybody understand this? And we also previously said this. The parent radical function is this. Yes? Okay. So we pretty much know how to do this, right? Okay. Now we're going to learn some properties of radical expressions. What does that mean? Okay? If I said x cubed times x to the 5th, what is this? X to the 8th. Got it? Okay, what about this? Square root of 3 times the square root of 5. What is that? The square root of 15. That's what we mean. How do you deal with radicals? Does that make sense? Okay. So there's some basic principles. Okay. The first concept that you have to understand, what does it even mean to have a square root of something? What does that mean? Well, we know what square root of something means, right? That means you take the number and you multiply by itself. Correct? So if you have 3 squared, you know what that means. That's 9. How did you know that? Because 3 squared is 3 times 3. That's what that means. Square. Same thing, 3 cubed is 3 times 3 times 3. So you have to know what this means. Now, somewhere in the history of mathematics, somebody decided to put it over there. They could have put 3 squared as over this. And people have said that's 9. You follow what I'm saying? Nobody said it had to be over there. Yeah? Somebody could have done it over here. But it's just the way it was decided. So first you have to understand what it means to have a square root sign like this. So just like x squared means x times x, what does this mean? Okay, so everybody knows square root of 9 is what? It's 3. Why? Because 9 is 3 times 3. So in this symbol here, okay, there's an invisible 2, which we don't write. Why? Because it's the most common square that we take. Okay, you can have cube root of something, right? Or the 4th root of something, right? Or the 5th root of something. You follow? But we usually take square roots. We usually take them so much that we don't write it there. Does that make sense? Yes? So, don't you say square root of 9? Don't you say 3 squared? Right? You take square root of 9. You say 3 squared. Right? This is 3 cubed. This is, yeah, 3rd root of 9. You understand that? Cube root of 9. You follow? So even when you articulate it, square root of 9, square root of 9, you're saying it, but you're not writing it. Does that make sense? So when you say square root of 9, it means what 2 numbers, when you multiply them together, give you 9. Okay? When you say cube root of 9, it means what three numbers, when you multiply them together, give you 9. When you say fifth root of 9, you're saying what five numbers, when you multiply identical numbers, when you multiply them together, give you 9. Does that make sense? So, first you have to understand that. Okay? Now, the square root of 9, therefore, is 3, because 3 times 3 is 9. Now, the cube root of 9 is not a nice number, right? Yeah, it's going to be an irrational number, right? But how about a cube root of 27? That's a nice number, because what is that? 3 times 3 times 3, right? So cube root of 9 is 3, because it's saying what number multiplies itself by itself 3 times. You follow? Does that make sense? Okay? How about this? Cube root of 8. What does that mean? That means what number multiplied by itself 3 times give you 8? What number? Yeah. So the cube root of 8 is 2. Does that make sense? So, the first thing you have to understand, what does it mean? Okay? Now the square root of 8 means, now look, I didn't write the square root, I said it. Right? But I didn't write it. But there's a 2 there. You follow? Square root of 8 is, it's not a neat number, it's a rational. What is it? Can you plug it on the calculator? Can you do that for me? Blah, 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 right? Irrational number. Got it? Okay. So the first thing you have to understand is, what does this symbol represent? Commonly we take square roots, but in fact, you can take any root. You can take cube root, you can take ninth root, you can take a billionth root if you want to. I don't know why you would want to, but you can. In fact, you can take an nth root of something. Right? Does that make sense? This means n could be what? Anything. Does that make sense? Okay? Nth root of something. Okay? Alright. That's the first thing you have to understand. What does it mean to take the root of something? Okay. If you understand that, then you can do a lot. Okay. What's the square root of 9? 3. What's the square root of 25? 5. Yes? What's the square root of x squared? X. Right? Okay. So we're going to have to learn some properties. They're all very intuitive. They're easy to learn and also easy to forget. So you have to review them. Okay? You understand? But the review is the key. You learn better sometimes the next time around. Okay, what? Simple things. If there's a square root over here, and if there's square root over here, okay, A and B, okay, if they're two separate square roots, okay, you can make them into one big happy square root like this. A times B. Right? It's like one here, bring them together. Fair? That's easy enough. Okay. The opposite is also true. If you have a square root like this, you can make it into two baby square roots. A times this. You follow? Not square root of A plus square root of B or something like that. Okay? Now notice, I didn't also say if you have square root of A plus B, you can't do this. This is haram. Only multiply. Does that make sense? Okay. So this, I'm not going to write it backwards, but you understand it goes both ways. Okay? Alright, now, watch this. Now if you understand this, watch this. Square root of A squared times B. Get it? Same thing, right? I can separate this out, right? Yes? into square root of a squared times square root of b, right? Right? Okay. This is what? What's the square root of a squared? A times square root of b. Yes or no? Now look. Do you understand this? This means, another way of thinking about a square root is, okay, anytime you have a pair, okay, you can take it out as 1. Okay? It's like this, okay? If you have peanut butter on this side, if you have jelly on this side, you can combine them into a peanut butter jelly sandwich, take it out as 1 sandwich or 2 sandwich? 1 sandwich. Anytime you have a pair, they come out as 1. You follow? Okay. So, that's very important. Now watch this. So what's the square root of a squared? Anytime there's a pair, come out a, right? Because that's a times a. You follow? Now what's the square root of a cubed? Square. Right, because this is a squared times a, right? You can take out 1 peanut butter jelly sandwich. That's a times the square root of a. Does that make sense? Yes? Okay. So that's the first thing. So how do we see this? Now the square root of this, that's the key. Anytime you have a pair, just like a butter and just like peanut jelly, you can put them together and take it out as a peanut butter jelly sandwich. 1 sandwich, not 2. Do you understand that? Okay. I explained to you why that is the case. But you'll forget the explanation, but that's okay as long as you're able to apply the rule. Okay. Now, considering that, okay, if you have an answer like this, now, if you have an answer like this, okay, would you leave it like that? It's just like saying, 18 divided by 2 is the answer. Yes? You want a lollipop, little one? No, that's babyish. You want to simplify. So you want to simplify your expressions as much as you can. Does that make sense? So we have to learn how to now simplify radical expressions. Do you understand this? Okay. So how do we simplify radical? I'll give you an example. What do you mean by simplifying radical expression? I'm not simplifying no radical expression, right? You must be careful of you. What do you say, little one? Because now I have a mask on. Okay, just kidding. So, you follow? You notice I'm not coughing, right? Warms up the air. Okay. I breathe easy too. Watch. What do you mean simplify radical? Watch this. Square root of 50. Okay, if you punch this, it's not a perfect square, right? Square root of 49 is what? 7. But square root of 50 is not a perfect square. It's therefore a rational number, right? Or yes? Wrong. Rational number? Irrational number. Welcome back. Pay attention. It's an irrational. Any square that's not a perfect square is irrational. So square root of 50 is irrational, right? But can we simplify it? What does it mean to simplify it? Okay, well, you break it into its factors. 50 is what? 25 times 2. Now I have a perfect square. When you're doing this, you're looking for perfect squares. You understand? Perfect squares. Now, because this is what? What's the square root of 25? Okay, so look. This is square root of 25 times square root of 2. You agree with that? Yes? Let me do it slowly. This is square root of 25. This is square root of 25 times 2. Agree? And this is square root of 25 times square root of 2, right? Okay, how? Because I just gave you a rule. If you have a square root of a times b, that's equal to square root of a times square root of b. And vice versa. If they're in two separate umbrellas, you can bring them together. If they're together, you can separate them only with multiplication. Yes? Okay. Now I've done this. What's the square root of 25? 5 last time I checked. 5 times square root of 2. So this simplified to this. Yes? That's what it means to simplify radical expressions. Okay? Do you understand this? Okay, now we did this, right? Now you're not going to do all of this, okay? This is just one, this is the way you would do this. Okay, okay, I'm going to divide this into factors. This is 25 and 2. Okay, this is going to come out of peanut butter jelly. That's going to be 5 times square root of 2. Do you understand that? Okay. You can do the other way too. Watch this one. Square root of 18 times the square root of 2. Rational or irrational? Okay. But we know this rule, right? Square root of A times square root of B equals square root of A times B, correct? So let's do this. Can we bring this into one big nice hype umbrella? What's 18 times 2? What's square root of 36? Ah. Do you see that? So sometimes you can simplify it, you can do it simplify like this. The other time we did the opposite. We divided into this. Do you understand this? So sometimes you do this to simplify, sometimes you do this to simplify. Does that make sense? So the first radical rule that we learned is this. Square root of A times the square root of B equals square root of A times B. Both ways. Make sense? Okay. Now, that's one concept. One property, okay? One property. Alright. Square root of 5 plus square root of 2. Okay, what is this? Square root of? It's square root of 5 plus square root of 2. You can't simplify it. It's a trap. How's a trap? It's a trap. You can't simplify. Because these are like, not like terms, so to speak, okay? But, so that's what we're going to learn next. When can you add? When can't you add? So, watch this. 2 square root of 5 plus 7 square root of 5. Okay, this is 9 square root of 5. Okay, I'm going to lay x be 5. Okay, I'm going to say x is equals square root of 5. Okay, got it? Then this is like 2x plus 7x equals what? 9x. Do you understand? Okay, now watch. 2 square root of 5 plus 7 times square root of 3. So x is this, y is square root of 3. So this is 2x plus 7y. Can you add those? No, how do you add x and do you follow that? They're not. So square root of 2 times square root of 5, these are like x and y. You can't add them. Can you multiply them? Yes. What's square root of 2 times square root of 5? That's square root of 10. Do you understand that? Yes? Yes? Oh. Yes? Okay. Now, so what did we learn? We learned how to multiply radicals. Okay? We learned how to add radicals. Okay? For you to add radicals, they have to have the same radicand. That's the inside. Okay? So let's do some of that. Alright? So watch. So 11 square root of 3 minus 7 square root of 3. What is this? Let's start from here and go this way. 4 square root of 3. It's like 11x minus 7. You understand that? Okay. So, How about subtracting? How multiplying? Right? How about this? 2 times, okay, 5 minus 4 square root of 3. We're going to distribute this, right? Now you understand you can't add these anymore, right? You understand that, right? Yes? Okay. So we're going to distribute, just like before. That's going to be 10 minus 8 square root of 3. Does that make sense? Okay. Okay. What you need? Okay. Square root of 3. Okay. Times square root of 8 minus 4. Let's do this. You can do it progressively. Yeah, square root of 24. Very good. He did it in 2 steps. Square root of 3 times square root of 8, and he put them in the same umbrella. It's 24, right? Like 20. 24.
Square root
Minus?
minus 4.
Minus 4? You're distributing. Square root of 3. Yes?
Yeah.
Does that make sense? Yes, yes, yes? Are you done yet? No. No, no, no. Just like I gave you this, 18 times square root of 2. You couldn't simplify this, but you got 36, so you get a nice, neat number. Maybe you can get a nice, neat number here, right? You always try to simplify. So how do you simplify this 24? It's not going to simplify, right? How are you going to simplify this?
You may break it down. So 8 and 3. No. What?
You have 4 and 6. Right? Okay. Let's say you didn't know that. You did 8 and times 3. You can't take out an 8, right? But the 8 is what, like 4 times 2, right? You can take out a 4, but these two are still inside. Okay? We'll do more of this. But here, let's do it like this. 4 and 6, right? You can take this out as a peanut butter jelly sandwich, right? That is 2. 2 times square root of, what's left inside? 6 minus 4 times square root of 3. Can you simplify this? No. That's it. Does that make sense? Okay. Yes, sir.
The last one, when you said 8 times 3, I think, you said, so how would you do that? And then this splits into 4, and then 4 factors out 2.
Yes. Okay. So if you did this, look at this. Square root of 24, okay, it's 8 times 3, right? Another way of writing 8 is what? 2 times 2 times 2. And there's a 3 here. So these are all the factors, right? You can only take out peanut butter jelly sandwich, right? 2 at a time, right? So these 2 can come out as 1, right? So it'll be 2. There's a 2 left inside, 2 times 3. So when you factor stuff, so you say 24 is the same thing as 2 times 2 times 2 times 3. Correct? That's what you do when you factor. You put this 3 thing in to make it easy for you.
It would be 2 to the power of 2 square root of 6.
Yes, 2 times square root of 6. Like the same as this. Okay? Okay. Now, watch. Okay, I'm going to do some of these problems, okay? So, okay. Let's do some of these problems. Alright, so, square root of 18, square root of 125. Let's do that one. Square root of 125. I don't need this. Oh, okay, this is, what's my thing? How do we do this? You have to break this down into? No, you have to break this down into its factors. Yes? So what are the factors to 125? If you don't know, what do you do? Yes, you always ask them. Use your what's one number that goes into 125?
25.
5 goes in there. So what's 5 times what?
15.
Very good. 25. Right? Right? 5 times 25, right? Correct? Now, see, that's this. What can you take out from here?
25,
Yes, so you can take that out, right? It's peanut butter jelly sandwich. Correct? So that's what? That's 5. And then what's left inside?
20.
No. Alright. Okay. No. Watch. What? Okay, resuming. Resuming transmission. Commence deploying the troops. Okay. We did that one. What the? Okay, who wants to do this? Whose turn is this? 72. Okay, you want to redeem yourself. What the? Okay, let's do square root of 72. Square root of 72. Now you have to divide this into its factors, right? So what goes into 72? 2 goes in there, right? This is your turn. Yes. How many times? Like this, right? Yes? So then what? Uh-huh. 2. You got it? 6 squared root of 2. Okay. We did that one. Everybody got that, right? Okay. Who wants to, okay, we'll tell. B to the power of 7. Okay.
3b.
To B or not to B. No. No. You can take 2 of them out as a pair, right?
Yeah.
Right? So that's like B squared times B squared times B squared. That's 6. And B, right? That's 7, right? So each of them can come out as 1, right? How many of them come out? 3 of them come out. So that's B cubed. How many left? 1. B. Do you understand that? You follow? Okay. How about this one? Mama Patel.
That would be.
Now you're getting it, right?
Yeah.
Even numbers can come
B, part 5.
like this, right? Even numbers can come out. Right? Now you're getting it, right?
Yeah.
Every even number can come out half of them, right? Because, you know, if you have 10 pieces of bread, how many peanut butter sandwiches can you make? 5. Right? Yes? So that's B to the 5th, right? How many left? Those 11 of them? 1. Does that make sense? Okay. We got that. Who wants to do this one? 75x7 y5. We go this way, sorry. If he's sleeping. Is he sleeping? Or okay, square root of 75. What was that? X to the square root of 75, x7, y5. Okay, Abdullah, let's do this. I just want to let you know you're being recorded. So you may want not to speak as loudly as you usually do. So now you have to take one of them at a time, right? So let's do this one at a time. So, can you simplify square root of 75? To break it down into its?
5 square root of 3.
You go a little fast for me there. So you're saying it's 25 times 3?
Oh, yes.
Okay. You right? You right?
Yeah.
and then you're taking out the 5, right? And then inside you're going to have 3 left, right? Right? Okay. Good, but you can simplify the x's and y's too, right? So x7, right? Mm-hmm. So x7, how many peanut butter jelly sandwiches? X6 times x1, right? So how many sandwiches? So there, what I write here? X cubed. There you go. And how about y? But then there's one x inside, right? Don't forget it. Yeah, put that back in the fridge. Yeah, one left, put it back in the fridge. Okay. How about the y's? You have 5 y's. That's y4 times y1, right? Right? If it's odd, right? There's going to be 1 left, right? So how many, what do I write? Y squared. Y2 is kind of like not cool enough for us. And 1 y left, right? You got it? Yes? So this simplifies to that. Does that make sense? Okay. 27, A11, B7. 27, A11, B7. You have to remember the problems. 27. Hold on. I want Abdullah to do this one again. Okay, Abdullah. Factors. Very good. So what comes out? And then there's going to be something left in the fridge, right? How about the A's? Yes, it's going to be 10, 8 to the 10 times 8 to the 1, okay? A to the 5th, and what's left? Okay, how about the B's? Very good. B. Got it? Very good. Okay, let's do 32A7B4. 32A7B4. Okay.
I got the factors from 32, 8 and 4, or 16 and 2.
I didn't mean to do that. If you did 8 and 4, let's see, he did 8 and 4. Right? Then you say you could take this out, but then there's 8 has factors too, right? Which is 4 and 2. You could take that one out too. Yes? You just have to make sure you take as much of them out as you can. So 16 and 2, right?
Yeah.
Okay, so what comes out, what stays in?
4 is out, and
Don't-
then 2.
Okay. And then, look, I give myself some room to put the other stuff there, okay? Because if you put like if you go like 4 times square root of, and then nothing there, yeah? Okay, so plan this a little bit. So this becomes 4 times square root of 2. Okay, now what? How about the A's?
A6 times A1,
Mm-hmm.
and then it's like A cubed, and then 2A,
Very good.
then B4
Mm-hmm.
is B2,
B2.
Yeah,
What about here?
and then another B2.
B2? No. If you have 4 pieces of bread, how many sandwiches can you make? 2. How many left for the fridge?
Oh,
Nothing. They're all. Yes, there's nothing for the fridge. You understand?
yeah.
It's just that. It's like square root of 16. It's like 6. You know, like 4, and there's nothing inside. You understand? Does that make sense? Okay, that's this. Okay. We need more practice, I think. How about 9A? You want to write some of this? Okay, you want to just write this down for me? Okay, do this. Everybody do this. Let's do this whole row. No, it's not the whole row. Do 11 and 13 and 15. Just write this down for me, okay? Okay. Okie dokie. See, this negative 3 is on the outside. It's like negative 3 times square root of this, okay? Just leave it be. See, there's a times. You follow? Okay, so don't worry about it until the end. So, that's just helpful. Okay, now what?
24 is 8 times 3.
You weren't really looking for perfect squares. That's okay. You can do that too. Yeah? Okay, so let's look at square root of 24, okay? So you can call it 8 times 3, but you can't take anything out, right? So you have to factor it some more. What's 8 goes, sis? 4 times? 2, okay. So 24 then factors into these 3, right? 4 times 2 times 3, correct? So you can take out the 4, right? What's left inside? So what comes out? As? 2. And inside is? 6, right? You follow? But you know what comes out of perfect squares, right? So if you know that, 24 is 8 times 3, but it's 4 times 6, right? Because that's a perfect square. So you want to see what are multiples of perfect squares, right? So what are, like, for example, let's write down some perfect squares, which are our good friends, right? In these cases, correct? So 2 is a perfect square, right? Okay, what's multiple of 2? 4. Yeah? They'll give you that, right? So, and then, 3 is a perfect square. So you're looking for these numbers, 9. Okay? 4 is a perfect square. You're looking for these. So these are the numbers to look for, right? You follow? And then 5 and 25. So if you have like this, square root of 75, you want to factor it 5 times, you know what I'm saying? It's like 25 times 3, that's a perfect square, right? You understand that? But what you did is not wrong, but it's longer. Does that make sense? Okay, so you're looking for perfect squares. Because it's easy to take square root of perfect squares. It's easy to take square root of perfect squares. It's like easy to take circles and put them in circles. Right? Do you understand that? Okay. So 24 simplifies to?
4, 6.
Okay, good. And I can take what out?
2.
So that 2, and what's inside?
6.
Okay, good. I'm done with that. How about the a's?
A squared.
So a squared. They come out as? The whole thing comes out. Anything left?
No.
Okay, how about b's?
B, just 1 B.
Just plain b. How about inside?
No.
Nothing. How about c?
C comes out and there's 1 C inside.
1c and then?
1 C inside.
1c inside. And then you have to simplify this, right? What's 3? Negative 3 times 2?
-6. A squared. B.
Square. Correct. Do you see that? Do you understand? Okay. Up to her. Leave it alone, right? Whoa. See what he did? See what he did? He said 48 is 16 times 3. That's very good. See? Because you know that's a perfect square. You can take it out, right? Smart thinking. You're getting it. Good job. Okay, that's 16 times 3. So 4 comes out times 4, and the 3 remains inside. Okay, now what? And? And inside? 1 left, okay? Mm-hmm. What's in there? What's inside? Umar desperately wants to point out your mistake here. He's like, the second he made it, his like hand went up right there, and he had a big smirk. Like, I would show it to you, but I have the scarf thing on. What do you do wrong?
You have to do b squared.
B squared. You can make 2 sandwiches out of 4 pieces of bread. Yes?
Yeah.
You made only one. You ate the other one, didn't you? That's what you did. Okay. You understand? You gotta be careful. But they're not done yet, right? Because, yes.
So, negative 8a b squared c square root of 8.
Got it? Okay, so that is the simplified answer, inshallah. So what did we learn here? We learned how to simplify radicals. Okay, so what we're going to do is, we're going to, when we come back after break, inshallah, we're going to learn a little bit more about this, and we're going to review how to solve radical equations with a little more complicated ones, so we know more, and then the test, inshallah. Okay, that makes sense? Until then, salatu wassalamu ala rasulillah.